So very good morning, students. So welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and Mastermind Schools. So once again, I welcome all the class 7th students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 7th. Today we are going to start a new chapter, heat. That is, we are in the session number 1, right? So after completing the pressure in the last class, today we are going to start a new chapter, heat. So you all know, in common, our day-to-day applications, our day-to-day life, heat plays very important role. If you just recall from morning to night, for example, when you wake up from the bed, we'll boil the milk for preparation of tea, coffee, or any other. When you are going for the bath, we'll get the geyser or heater to make the water hot for bathing, especially in winter. When you go outside, we can see the heat from the major source, that is sun. So you can easily feel the heat at every moment of our life. Either it may be external or it may be internal. When there is a disturbance in the food process, again heat is generated in the body also. Such a wonderful word which has many applications in our day-to-day life is heat. So with the heat we can do many works. So many works we can do. That's why it is a form of energy, because we are doing some work with heat. So it also comes under the form of energy. And we'll see what are the sources of heat. Right, today, what are the source of heat, from where heat will come, and what are the effects of heat. Right, then how heat will flow from one place to another place, that is comes under transmission of heat. Right, also expansion, how the expansion of solids, liquids, or gases when they are heated. There are many applications of heat in our day-to-day life. Along with that, when heat comes, another important word comes is temperature. Right, when a body is heated, its temperature rises. When body is cooled, its temperature falls. So heat and temperature are the very relative terms. So today we start with what is heat, how heat is measured, what is the unit of heat, what is the branch which deals with the heat, and what is temperature, and what is the difference between heat and temperature. Then we'll go for the remaining part, like source of heat, effect of heat, how heat is transmitted from one point to another point, and how the heat affects the solids, liquids, or gases in expansion. Many more things we'll discuss in the coming 2 to 3 sessions, right? So as a part of that, you can see the textbook, page number 118, right? We have to see here what we are going to learn in coming days. The first one is introduction. If you see, the branch of physics deals with the measurement of temperature is called thermometry. Similarly, measurement of heat is called calorimetry. Right? Dealing with the heat is calorimetry. Dealing with temperature is thermometry. The property that tells how hot or cold a particular body is called temperature. So the degree of hotness or coldness of a body is called temperature. When a body is heated, various types of physical changes, that is effects, what happen when your body is heated. So there is physical changes takes place, that is length, breadth, volume, size, dimension, everything may increase, such as expansion, contrast, change of state from solid to liquid. Suppose when ice is heated, it becomes liquid. When liquid is heated, become vapor. And change of electric property, they may become conductor to insulator or semiconductor. There will be chemical changes. So all these are the effect of heat. When a body is heated, it undergoes many effects. It may be physical effect, it may be chemical effect, it may be change of state. That is, you have seen the last year, 6th or 7th class in chemistry also. Chemical changes and physical changes. This is happening because of the heat only. Right? Now come to what is the difference between hot and cold. Hot and cold. When heat is supplied to a body, its temperature increases. When heat is taken away from the body, its temperature decreases. Right? When you supply the heat, heat temperature rises. When you remove the heat, temperature falls down. Heat always flows from body of high temperature to body of low temperature. This transverse heat continues till both bodies attains same degree of hotness or coldness. Very interesting. For example, if you take one body with a temperature of 10 degrees and you place another body here, temperature of 20 degrees. These two are in contact. The two bodies of different temperature are kept in contact with each other. Heat always transfers from hot body. Say this is a hot body, this is a cold body. Hot or cold or high temperature, low temperature. Heat transfers from hot body to cold body. Up to where that are, see, 10 plus 20 are there. Total is 30. So till both become 15 and 15, the heat keep on transfers. Suppose your friend sitting beside you is having the high temperature. He is sitting with you, you are in contact. So his body temperature is say 100. Right? Your body temperature is 98. When both are sitting together, the heat transfers from your friend to you. That's why it make the when the fever person is there or infection is there, move away. So heat transfers from you to you until both become 99. You will also catch with the fever. Similarly, every heat happens like that only. Heat transfers from always from hot body to cold body until both become same. And that state is called thermal equilibrium. When the two bodies of different temperature kept in contact with each other, heat flows from hot body to cold body until both have the same degree of hotness or coldness. And the process is called, whether it's called thermal. Thermal is nothing but heat only. Thermal equilibrium means both become same temperature. Right? Here. So, two bodies are said to be thermal equilibrium with each other if they are at the same temperature. Therefore, it is the state of body where it neither receives nor gives out the heat because already they are attains the same temperature. Further, they cannot go for the either to receive or give out the heat. Such state is called thermal equilibrium state. Right? Now come to our core topic, that is heat. The energy transferred from one body to another body due to difference in their temperature is called heat energy or thermal energy also you can call it as. Heat is a form of energy which makes any object hot or cold. Heat energy is also called thermal energy. Right? So units if you see, SI unit of heat is joule because it is energy only. Joule or erg. And another common unit is calorie. Heat also measured in calorie. Either joule because it's a form of energy is also measured in the calorie. What is calorie in joules? See, this is very important relation. 1 calorie is equal to 4.2 joule. Joule, huh? Right? Then heat is a form of energy. Its unit is same as energy. Heat is a scalar quantity. There is no direction for heat. It can travel any direction. Then temperature. So wherever heat is there, temperature either increases or decreases. If you pass the heat, if you give the heat, temperature rises. If you absorb the heat, removes the heat, temperature down. So temperature is nothing but the degree of hotness or coldness of a body. We can feel the temperature also by touching. Suppose touch when hot bowl, same time touch the ice piece. We can feel one is hot, one is cold. Such hotness or coldness of a body is called. So, for example, in summer, temperature is 42 degrees. In winter, temperature is 0 degrees or minus degrees or 5 degrees, 6 degrees. So that is one is hot, one is cold. Winter is hot, summer is cold. Winter is cold, summer is hot. Right. This hot and coldness is measured in terms of degrees. 42 degrees, 3 degrees, 4 degrees. Right. So the degree of hotness are called temperature. Temperature is also a scalar quantity. The reliable method to determine the hotness of the body is measuring is its temperature. If a body is hot, its temperature is more. The body is cold, its temperature is low. So the temperature is measured in SI system with Kelvin or Celsius and Fahrenheit. Three scales are there to measure the temperature. Commonly Kelvin, regularly Celsius, rarely Fahrenheit. Which are the units for the temperature, that is the degree of hotness or coldness of a body. The temperature also what means 42 degrees, 38 degrees Celsius, like that we measure. Even we can convert into Fahrenheit also. They can be converted into Kelvin also. The conversions we see in the coming classes. Right? So this is about the heat and temperature, the two important terms. So just we'll see that table and then we'll move to the one video about this. Okay. Before going for the measurement. See table, you can see table clearly. Right? Not I can zoom also a little more. So clearly you can see what is the difference between heat and temperature. Right. So heat is a form of energy which causes the sensation of hotness or coldness. Temperature is the degree of hotness or coldness of the body is measured as temperature. Heat is a cause. Temperature is the effect. Means heat is a source. Without heating, we cannot get the temperature. When you heat the body, then only the temperature rises. Whenever you remove the heat, temperature will slow down. So heat is called cause, temperature is called effect. Just like force is a cause, motion is an effect. Without force, you cannot make the body to move or stop. So it is measured in joule or calorie. It is measured in Kelvin, Celsius and Fahrenheit. So heat always flows from a body at high temperature to low temperature. Temperature is determined by direction of flow of heat. So calorimetry is used to measure the heat energy. Thermometry is used to measure the temperature. So very, very important differences between the heat and temperature. Right? So these are very important relative terms which are connected to one another. They are connected to one another, that is heat and temperature. So before going for the further explanation, let me show you one video on the same. Then we move to the
Hello and welcome to Science for Juniors, I am Scientist Radhe Krishna, or SRK, as I'm famously called, and this is my assistant Bin. We are doing this experiment to help. Ouch! Burnt myself.
Professor, let me get you some ice. It will cool down your skin.
Oh, Binny, the ice is not going to cool my skin. Instead, it's my skin that'll melt the ice with its heat.
But Professor...
You see, it's my hand that will give out heat to cool itself. Binny, you, like many of my students, need to understand the concept of heat and temperature well. You need to understand the difference between these two quantities. So let's enter the virtual world.
నా గ్యాంగ్స్టర్ స్టోరీస్ అంటే చాలా ఇంట్రెస్ట్ అన్నా ప్లీజ్ నీ ఫ్లాష్ బ్యాక్ చెప్పన్నా
హీరో పెద్ద ఇలాఖా
Heat and temperature. In this module, you will learn about the concept of heat and temperature. If you touch a cup of tea, it feels hot. If you touch ice cubes, we feel cold. It is very important to quantify and measure the difference in warmth of an object. This need introduces us to the concept of temperature. Temperature is defined as the degree of hotness and coldness of an object. Temperature is measured by an instrument called a thermometer. The SI unit of temperature is Kelvin. 273.15 K
That we learn later.
is equal to 0 degrees Celsius. Let's now learn to calibrate a thermometer.
So this is the next anyway. Not
For this,
now.
first place the thermometer in ice and mark the melting point of ice, that is 0 degrees Celsius, as lower fixed point of the thermometer. Next, place the thermometer in boiling water such that it does not touch the boiling water that shows the temperature of the steam. The boiling point of water, that is 100 degrees Celsius, is marked as the upper fixed point. The separation between these two fixed points is divided into 100 equal divisions, each representing a temperature difference of 1 degree Celsius. When I was a little boy and fell sick, I was fascinated by these things my mother...
Professor, the thermometer.
Oh, of course. You know that energy only gets transferred from one body to another and never gets lost. So it is with heat energy. When you have fever, the heat energy from your mouth flows to the mercury in this thermometer, which expands from the heat and registers the temperature.
So that means, Professor, that temperature difference between two bodies also shows the direction of energy flow, isn't it?
That is a brilliant observation, Binny. On that note, we get ready to enter the virtual world again. Temperature is often thought to be the same as heat. But this is not true. Though they are related, but there is a difference between them. To understand the difference, consider a glass and a large vessel, both completely filled with hot water at the same temperature. Though the water in the glass and the vessel are at the same temperature, the vessel has more heat as it has more mass. Heat, thus, is a total amount of energy in the substance, whereas temperature is the average energy of the molecular motion in a substance. Consider two glass containers filled with water. One container is at 70 degrees Celsius and the other at 20 degrees Celsius.
Observe carefully how the heat transfers.
The molecules in the water at 70 degrees Celsius will vibrate more vigorously than those in the water at 20 degrees Celsius.
That is the
Why do you
reason why
think this
heat
is so?
differentless.
The molecules in the water at 70 degrees Celsius vibrate more vigorously because the average energy due to the motion of molecules in hot water will be more than that in cold water. Back from the virtual world and into the lab with Binny and me. Oh, Binny, don't touch that. You will get burnt.
Oh, that didn't look that hot.
Ah, Binny, objects at about 54 to 55 degrees centigrade or 130 degrees Fahrenheit are usually warm enough to cause you pain. So please be careful touching things unless you are sure they are near to your body temperature of about 36 degrees centigrade or 98 degrees Fahrenheit. Heat flows when there is difference in temperatures of bodies in contact with each other.
Difference in temperature? Professor?
Yes, Binny. You see, heat is energy in motion. Heat is energy in transit. Heat cannot be said to exist unless there is one system in contact with another system of differing temperature. Let's understand it better. You will now learn how heat and temperature are related. Consider water in a beaker at room temperature. If you heat the beaker, you can easily make out that there is a rise in the temperature of the water. This indicates that as heat increases, temperature also increases. All you can say is that the average energy due to the motion of the molecules also increases. When two bodies at different temperature are brought in contact with each other, heat flows from the body of higher temperature to the one at lower temperature. The flow of heat continues until both the bodies attain the same temperature. At this stage, the two bodies are said to be in thermal equilibrium. Consider two beakers, one containing 250 cubic centimeters of water
Volume, that is 250.
and the other containing 500 cubic
double the
centimeters of
water.
water. If you heat the water in both beakers at 100 degrees Celsius,
Both are 100 degrees.
you will observe that 250 cubic centimeter of water takes less time as compared to 500 cubic centimeters of water. You can conclude that where there is greater amount of the substance, the greater the heat required to raise its temperature.
Right. So this is the commonly observed. We'll move to the next one. Next class we'll see. So in this particular beginning, so we are very much clear about what is heat, what is temperature, and you all seen the in difference also. What is the thermal equilibrium? How heat will flow from one body to another body. Okay, till the attain the same temperature we have seen. Right. Now just when we continue with the temperature, measurement of temperature. Measurement of temperature. So temperature is measured by a device called thermometer. So almost all of you know about the thermometer. We used to measure our body temperature with clinical thermometer. The property of expansion and contraction of substance due to heating and cooling is the thermometer. So thermometer works on the principle of expansion of heat or contraction of heat. So mercury used in the thermometer, very important. Advantages of mercury as thermometer liquid. Why using only mercury? Why not water? So first advantage, its expansion is uniform over the wide range of temperature. Even you are hitting up to 1000 plus degrees Celsius also, the expansion is consistent. Because of that, we are using the thermometer in the mercury in the thermometer. It is a good conductor of heat. So it has low heat capacity. It is opaque, means does not allow anything to pass through. Shining and clearly visible. So while raising also, you can see the constriction will raise because of the clear visibility of the mercury. It does not wet the glass. It does not touch with the glass also. Because when you drop mercury down, it is split. It never touches the floor also. A special property. It is easily available in the pure form. It is high boiling point and low melting point. It exerts very low vapor pressure. Because of all these properties of mercury, it is taken in the thermometer. It is used in the thermometer instead of any other liquids. So, its expansion is uniform, even wide range of temperature also. It is a good conductor of heat. It becomes very quickly compared to others. It has low specific heat capacity. We'll come across what is specific heat I will explain you. It is opaque, means does not allow shining and clearly visible. It does not wet the glass. It is easily available in the pure form. It has high boiling point and low melting point. It exerts very low vapor pressure. All these are the characteristics of mercury. Why the mercury is in the as a thermometric liquid. Right. Then next one is measurement of temperature. How to measure the temperature? Right. So temperature. One is construction of thermometer and second one is calibration of thermometer. Calibration means how they are marked. So they mark from 0 to 100 on one thermometer. Other type of thermometer maybe have different calibrations. Calibration is nothing but marking on the lens glass. Right? So these are the measurement of temperature requires two. One is thermometer should be constructed and it should be marked. So purpose we are using for the medical purpose. Take human body temperature. The calibration is different. When you want to measure the temperature of acids in the laboratory, there is a laboratory thermometer. The markings are different. As per different requirements, we'll use the thermometer we design. We'll construct thermometer accordingly. Right? So as you move forward, right. So it is the construction of thermometer here. So this is a glass, a very thin capillary tube. Capillary means throughout from top to bottom, same thickness. Tube, uniform cross section, one end of which is very thin glass bulb. This is filled with the mercury. And other side of the end is provided with the funnel. Here is the funnel is there to fill the required liquid. Is taken. The capillary tube is protected by means of thick glass stem as shown. So this is a capillary tube and this is a thick glass cover. This is a complete cover, glass tube. Right? So the inside is a capillary tube. Capillary tube is a very thin and uniform area. It is protected by the glass. Like a bulletproof when you wear like that. Right? Mercury is poured into the funnel. From here we are making the mercury flow into the capillary tube. The mercury is drips down into the capillary. It come up to here. You can see mercury here. But in this process, some air bubbles may get trapped. The bulb is heated into the water bath. After filling this, they'll heat the bulb into the water bath so that the air bubbles will come out. Come out, then they'll seal it. So such that trapped air escapes through mercury. Right? Whatever the air bubbles are there, air is there, it will come out when this construction is placed under the hot water bath. After that, they'll move to this process repeated several times. Several times till the glass bulb and capillary tube are completely filled with the mercury without any air bubbles. Finally, the funnel is out and entry the sealed. After that, after completely filled with mercury, they remove the funnel and this part is here, it is sealed. Now we'll get the thermometer which is ready to use. It is ready to use. Right? By the way, we can conduct the thermometer. That is construction. After construction, very important part is how you calibrate the thermometer, how you mark. So very important, there are so many steps are there to calibrate, which we'll discuss in the next class. So how to mark the numbers. It may be clinical thermometer, it may be laboratory thermometer, it may be 6 maximum minimum thermometer to measure the atmospheric pressure. So many are there. Depends on requirement or our need, we will have the calibration part. So tomorrow we'll discuss about how to calibrate the thermometer, followed by what are the different scales of thermometer, how you measure the thermometer in Celsius scale, Fahrenheit scale, Kelvin scale, Romer scale, and how to convert one value into another also in the next meet when you see in the next class, that is coming Tuesday, right? So after that, there is a transmission is there, transmission of heat, how it will transmit from one place to another place, followed by expansion of heat also, right? Clear all of you? So that's all for today. We learn about mainly about the temperature and heat, two terms, and how to measure temperature, how to construct the thermometer, and everything we learn. In next class, we'll see about the how to calibrate the thermometer of different purposes which we are using. So that's all for today. Thank you, students. Have a wonderful day. Thank you.